Hey there, today we'll be doing this question from our graph playlist that we are continuing so far, and all the videos till day 4 and coming on to day 5, everything has been uploaded. Now, the question statement that we are doing is 1091 shortest path in binary matrix from Leetcode. The question statement is given an n cross n binary matrix grid, return the length of the shortest clear path in the matrix. If there is no clear path, return -1. A clear path in a binary matrix is a path from top left to bottom right, and we can move it directionally. So let's understand this in a simple manner. So basically, the question tells you that you will be given a matrix, and you can go only to the zero numbered cells. Okay, and you can move in all the 8 direction. Till now, we were moving in only the 4 directions, right? Now we can move diagonally also, basically something like a chess queen. Okay, the queen in chess can move in 8 directional. So this is what we'll be following here. So what is the minimum number of moves you need to do in order to reach that? So this is a typical question that also comes in some few contests. Okay, so this is a typical question that we can do, and we can use BFS here. And how we are going to do that? We just going to start from the first cell that we have right here, and we'll try to move on all the 8 directions that are possible. That is something like this. In all the 8 direction, we'll try to move on, and whichever guy reaches first to the bottom right corner of the cell, that is the distance that we are taking. And how do we do that? Let's see this. So this is going to be starting from here. Now what can we do? We can move right, down, and down. Number of moves that was required was 1, 2, 3, 4, and 5. We reached here in 5 moves, and they are also counting where you're starting from, okay, as a one move. So that is why we need to return 5. And let's just say if we had something like this, what if this was 0? What would have happened? So if we start from here, that is 0 comma 0, the cell, we can do what? We can move simultaneously here and here as well. If we are doing BFS in one move, we moved here. Fine. This is our first move. Now second move, what can we do? We can move here or here or this one, right? So this is our second move. This is what BFS is, right? Traveling level wise. So this is our level 2, in which we reached these many cells. This is our level 1, in which we reached these many cells. So in our level 2, we can see that we actually found out a value that reached the bottom right cell. So in how many moves did we reach? We reached there in 2 moves. What did I select? Okay, so we reached here in 2 moves. Fine. So this is what you need to return. And there is also a longer path that we have taken right here, which will not be accounted for. Why? Because we need to return only the minimum number of steps that we can reach there. But what if we had something like a maximum? What did we do then? What have we done then? Okay, so coming on to this part, if we had something like a maximum, what could have been done is we would not return this exact cell, but instead we would have waited for the maximum one, and we would have maintained a maximum variable. But this question is not asking you that. You just need to return a minimum one. Fine. So whenever you encounter a cell that is the bottom right one, you just return the number of steps that you have taken. Fine. And let's understand with the code. This question is a simpler one. So you need to maintain the coordinates, and this is a 8 directional coordinate for dx and dy. If you have been following this playlist, you must know the dx dy for 4 coordinates, and this is for the 8 coordinates. Okay, so this is done, and this function valid is just to check that if we are going out of bounds or not. That is the only thing that valid function does. So you need to also take care of some edge cases. And what are the edge cases? Let's understand. So the edge cases can be, let's just say that if you have a matrix, I'll just erase this part right here and I'll explain it to here only. So whatever we have something like 1 here and 1 here, we can never reach it, right? Because we are starting from 0 0. If this cell is not only 1, then how can we reach to the bottom cell? right? So this is one of the edge cases where you have to return a -1. And what if this is 1 and this is 0? That means you can start, but you can never reach the bottom cell. Then in that case also you have to return a -1. Now what if every cell is 1? Then again you can never reach. So that is why a -1 again you have to return. Now what if you have a cell something like, let's just say this. This is your matrix. Let's just say this is your matrix 0. So you start from here and you end also here only. That is your starting cell is your ending point. Then in that case also you need to return a true or just one. Okay, since we can reach in just one move itself, and mind you, wherever we are starting from, that cell is counted as a move. Fine in this question. So let's now get on to the code part. Here we have created a queue, the basic and the classic BFS part, and after that we mark that as visited, and I'm marking it in the same array that has been given to us, the 2D array that has been given to us. And I have initialized a steps counter which says, okay, these are the number of steps that I have taken, and since the starting coordinate is also counted as a step, so I've marked it as 1. After that, we increment our step. Why? Because we'll be jumping level wise, as we found out here that we are jumping level wise. So if we jump level wise, the steps will be increased by 1, then by 2. Okay, so this is the part that is done. After that, we just iterate on all the values that are present in our queue. And what do? We just pop out the first value that is there, and we try to move out 8 directionally. That means if I just erase this part, I'll just start from here and I'll try to move it directionally in all the directions. Now, whichever value or whichever cell is actually valid in my eight directional point, I'll try to jump onto that point only, because these cell never exist, right? These cell do not exist. So there's no point in going on there. So we just validate that is the current cell that we are jumping onto, is it a valid cell? If it is, then only go. And also you need to take care of the fact that we can only jump to a 0. That has been also mentioned in the question. You cannot jump from 0 to 1. This is not possible. You can only jump from 0 to 0, all the cells which have been marked 0. So that is the part this has been taken care of. And at any given point, if while we are doing a BFS, if I can somehow reach this bottom right corner, then we'll just simply return the number of steps that I've taken. But if not, what do? We just push that value into our queue. That means I'll be jumping onto this part now, and again I'll try to BFS from there. And wherever I'm jumping onto, I'm marking it as visited, because we do not never want to jump back to the same index, right? Let's just say we're starting from here, you jump onto here, fine. But from this cell, that wherever you have jumped, you want to come back, that will cause an infinite loop, right? So you just need to mark that cell as visited. From wherever you are jumping to wherever you are jumping on to, you just mark that cell as visited. That means you cannot visit that again. So this is the part where we take care of that fact. And if we actually encounter any steps such that we reach the bottom right corner, we return a step, otherwise we return -1 as indicated in the question. Fine. So the code link will be in the description, and if you still have any doubt, please do ask me in the comments, and I've already submitted this course code. No need to worry about that part as well. And yeah, if you have any doubt, please do ask me in the comments. And yeah, thank you for watching. Please do like and